Okay, so we are back for our second day of exam 2. And this day we're going to start talking about springs. And we'll talk about springs in two aspects. We'll talk about springs in as forces and springs for energy. This example problem is focused on springs as forces. And we'll get into maybe a little bit at the end why this isn't on exam 1 where we're talking about all of our other forces. But for this problem, I have a spring. That spring is hanging, it's got a little hook on it. This is outdoors, this is meant to hold plants. It has a length to it when it's just sitting there completely empty of 1.5 meters. And it has what's called a spring constant. This is a property of the spring of 600 newtons per meter. Okay, and what we're doing in this problem is we are going to go ahead and add a hanging basket of flowers to the spring. So we've still got our little hook in here, but now we have our basket like so, and we'll put in our flowers. They're my markers, so only I can complain if they get mixed together a little bit more than they should. So I've got a hanging basket of flowers, and I'm told that the basket that I'm hanging has a mass of 10 kilograms. And what I want to know is what is my new length here. So I can say my what to find. All I want to know is how long is my spring now that I've added a basket to the end of it. How much is it stretched? And what's the new total length? Okay, we could jump right in with our spring equation, but the first thing we're going to do is still a force equation, and every time we're working with these force equations, we have started with a free body diagram. So we're going to go ahead and draw our free body diagram. I'm just going to go ahead and draw a dot. I've already drawn a pretty picture of a basket once for you guys. Hopefully that's enough. I have a force of my spring going up, and I have my weight of my basket going down. And I will go ahead and say that upwards is my positive direction. Great. Now we get back to, we're going to continue with stuff we're used to doing. Once we have our free body diagrams, we're going to write out all of the different equations associated with them. X, Y for each of our free body diagrams. In this case, we only have the Y. So I'm going to go ahead and say that the sum of my forces in the Y is going to be equal to my mass times my acceleration in the Y. In this case, hey, Mayflowers. Anyways, in this case, my acceleration should be 0. I don't want my basket to be constantly jumping around places. We will get to what that would look like, but that is not the next, that's the exam after this exam. So acceleration in this case, I'm assuming is 0. Sum of forces, I have a positive for spring. I'm going to just put Fs. I'm not going to write out spring each time. And a negative weight, mass times gravity, is going to be equal to 0. So my force of my spring is going to be equal to my mass times gravity, which is going to be equal to 10 kilograms times 9.81 meters per second squared. That is off the board. You'll have to trust that I wrote seconds squared there. That gives me a total force of 98.1 newtons. Okay, that is as far as we can currently get without any of our new content. So we're going to move on to our new content, which is saying that the force of our spring is going to be equal to the coefficient for the spring, so this is the spring coefficient, times the amount it stretches. Great. We want to know the total length, but the amount it stretches will get us a lot closer than we currently are. So the force of the spring, I guess this would technically be y in this case, but I think that spring equation is almost always written with an x just because it is. Force for the spring is 98.1 newtons. Our K value is 600 newtons per meter. And delta x is what we're solving for. So I'll divide both sides by 600. I get a delta x of 0.164 meters. This is not my answer, because what that number is the difference in height here. So we called that delta x. That's delta x. Hopefully with that, it gets really clear how we find our total length, because delta x and 0.5 appear to be the same as that length. So if I say 0.5 plus 0.164 is equal to my length, I get a length of 0.664 meters. And that is how far that my piece is hanging down. Quick example for today, that is my spring equation for forces. Got one more to go, but that's another video.